So I'm Karl Pfleger. I do three things. I donate in the space. I donate to the Buck Institute and Foresight and other charities in the space. And I run this website, Agingbiotech.info, which is what I often talk about. I also invest in startups in the space, and you can find, to the extent to which you're concerned about conflict of interest, which won't really be relevant in this talk today, but yeah, my full set of my portfolio is at my AngelList link here. You can actually get these slides if you want to follow along on your computer or phone at this URL, and the links are clickable, including all paper links. Normally I talk about the companies in space, and I'll do that again next year, but a bunch of things have come together to make me need to give this other talk today. So about stuff that slows down the field. And, I just heard a podcast with a Nobel laureate who said that science is 10% fact and 90% common sense. And we're going to talk about some of the common sense part today. So during the Q&A part, I'm happy to answer questions about any of those things that I said that I do, including all the companies in the how the commercialization of the space is going, or about the stuff that I'm going to talk about for 15 minutes. Aaron, can you give me a heads up halfway through the 15 minutes? This talk's going to have two parts. So the subtitle, the sort of provocative subtitle is when human data is not better, because lots of people like to say that it is all the time, and when RCTs aren't the gold standard, because lots of people like to pretend they're the only things that matter. And it's all about dose and mechanism of action and black boxes, non-homogeneous populations, and bad controls. So we're going to do just sort of a rapid fire, lots of text on the slides, go through them fast. It's a set of examples of a loose collection of things that are interesting, and then we'll talk about thoughts and lessons and what ties them together in the second one. So I'm basically going to take some hot shots at some of people's favorite things. Everyone knows metformin is great. If people on metformin, even if they're diabetic, which normally causes you to have much worse health, actually live better, longer than the age characteristic match controls. But who were these controls? So, we know that lifestyle has, so Robbie's question for Joe, was actually a perfect transition to this talk. We know that healthy lifestyle versus unhealthy lifestyle gives, and this is a great epidemiological review article here, gives a difference of 10 to 15 years. So, it's only about 50% effect. So was the metformin just repositioning people within the, another way of saying it is mimetic of some of your lifestyles? Is it just repositioning people within that 10 to 15 year variation? Rapamycin or other mTOR inhibitors. So everybody knows they're great. They're even better than metformin. It's like the greatest thing in the field, right? It extends lifespan by mice very consistently. Good large effects. But what were the baseline mTOR levels in these animals in the population under study in these RCTs? Well, they were ad-lib fed mice. What if we actually stratified the effect by the calorie consumption of the different mice? Or when we start testing in humans, what if we stratify by BMI? Or even better, by the direct measure of the primary mechanism by the mTOR levels, which can be tested. Sauna. Loads of podcasters and other people love to talk about the health benefits of sauna. Well, that's great. And, maybe when you're in a Scandinavian country and it's too cold to exercise outside, or you're injured or something like that. But relative to what, right? What were these control people in the studies doing with the 20 minutes or so the treatment group was in the sauna? Well, there's actually not very many. I looked at a bunch of the studies. There's actually a lot of these people just didn't have any instructions. It was sauna versus some of the control. But some of them tried to do placebo-controlled sauna. And what was the placebo? It was to actually lay down still for 20 minutes in this particular, slightly heated environment, but not hot enough to get sauna effects. So, to the extent to which they have hypothesized mechanisms of action for sauna, a lot of them overlap with exercise. Some of even sweat itself. So what about an iso sweat? controlled study for sauna? Like, what would that show? What would happen if you spent the sauna time exercising instead? Like, then what would the effect size be? That would be a kind of data that I'd love to see. So sauna is one example of, heat is one example of a hormetic stressor, and we know that hormetic responses are good for health, all kinds of them, right? CR, or calorie restriction or dietary restriction in general, fasting, cold, heat, all kinds of things. I didn't even know, when you start looking at the literature on hormetic responses, all kinds of things people have studied that I would think were just bad, but it turns out that there's some, if you do in the right dose, hypoxia, oxygen deprivation, radiation, dehydration, they call it intermittent drinking, which I think means something else in another time. The thing about hormesis literature is very little of the research is concerned with, everyone knows there's a dose response, right? There's, if you do too little of it, there's no effect. If you do too much of it, it's actually detrimental. There's some kind of a sweet spot. There's very little investigation of interactions between them. What if you do two different stressors of a different kind at the same time? Well, maybe they're additive in some way. We don't know. Does doing some of one change the position of the U-shaped curve for all the others, because the body's already under some kind of stress? These would be good things to know. What if, notice that some of the popular lifestyle factors that 10, 15 years I mentioned is all the normal things: diet, sleep, exercise, not abusing various kinds of substances. Some of those are themselves can be thought of as hormetic stressors, like diet being a little bit of calorie restriction. So maybe actually just healthy lifestyle is a little bit of hormesis, and that's moving the U-shaped curve for some of the other things. So whenever we're doing any of these other kinds of studies and we're getting excited about how great, radiation or heat or cold or whatever it is, maybe we need to think about it in these contexts. So I've talked about a bunch of things that are good and how we need some caution. There's also caution needed when the studies come out negative, right? So there's countless failed kinds of trials where maybe the failure is actually a mirage. So a good example of this is supplement studies of normal substances like vitamins. Most physiological variables in the body have a U-shaped range to their levels. And, many, for example, vitamin trial failures are actually the result of simply not testing the mechanisms of action reasonably. So a very common problem with several different kinds of vitamin trials are, people already have a plenty, they're already in the optimal part of the curve, and then you give them more, and well, that doesn't help very much, predictably. Or they're too low, but you don't give them enough, the dose problem. Or it turns out that the controls, the problem is the controls got it too, because it wasn't actually a special drug that only your factory knows how to make. And there's literature on this, right? There's the title of this paper, "Why Do So Many Trials of Vitamin D Supplementation Fail?" is very clear, and they talk about these things. You have to be careful with both positive and negative trials. Everyone's favorite thing, age clock reversal, and of course there was this giant viral thread recently about Brian Johnson's Blueprint program and how he reduces epidemic age by 5.5 years and 7 months, and it's a world record, right? There's no world record for this category. There's not a category of world record. There's actually a pretty good the ageless author Andrew Steele had a good rebuttal thread. So Morgan Levine has written extensively on how we shouldn't use these aging clocks as n=1. They're not designed to have that kind of repeatability, or they don't happen to have that kind of repeatability. And so there's lots of people who are over-claiming possibly exciting things, but you have to be careful on interpreting the results. So some of it's just common sense. So up till now, we've talked about sort of good things, positive trials or negative trials. There's also care needed when interpreting negative things. So this is another famous social media viral thing. It's a picture of a trucker who spent all his life trucking, and this is where his face looks asymmetrically. And people spread this around social media and said, "Oh my goodness, look how bad sun is. It causes all this DNA damage and blah, blah, blah." And clearly I should wear sunscreen every moment that I step foot outside. And it's amazing how many people express that kind of a view, right? But obviously dose makes the poison, right? If this guy was doing it 8 hours a day getting sun, maybe that's too much sun. Also, there's other caveats to the study, like maybe there were other exposures that were asymmetric. Meditation, okay, everybody loves meditation, right? But well, if you look at all the evidence of meditation studies, there's lots of good evidence. There's certain things that don't necessarily affect everybody: depression, anxiety. And then there's all kinds of studies on interesting populations, like super stressed, super busy executives. And yeah, when they take some time off and pause and relax, they get some benefit. That's great. But how much does that generalize? And what, just like sauna, like what could they be doing with the time besides meditating, right? If they're sleep deprived and they don't spend enough time exercising, is the meditation really as good as just sleeping more or doing a larger fraction of the exercise they should be doing for what we know is the right dose of exercise? And it's not just aging stuff. Mechanism of action and deeper understanding matter. There was all kinds of bad info going around about COVID boosters based on the antibodies waning and not even taking into account cellular immunity from T cells and B cells. Paxlovid is another interesting example. It got emergency use authorization from a trial that showed it was super, super effective in people who were not vaccinated. And that happened after, right? The study was done right before everyone got vaccinated, came out right after most people had gotten vaccinated and most people had gotten infected with COVID. So many more months before they had some data on how good is it in people who are actually vaccinated or previously infected. And then like some of the first data that came out showed it was really only beneficial at 65 plus. Okay, so that was okay, so this is the second half. So what do we have in common? What do some of these examples have in common? And if I didn't take a pot shot at your favorite thing, maybe not sure. So one of the things they have in common is that a lot of people, not all people, I mean, I know that there's smart people. I know that the people working on rapamycin don't make these mistakes, the smart people in our community, but there's a lot of people, and not just some researchers in the community and a lot of people outside the community who are just drawing over broad conclusions from these studies and this kind of data. So let's talk about some of them. First, this isn't the lifestyle advocacy talk. I'm not up here to say that all this technology is bunk and we should just do lifestyle. Lifestyle is very clear, won't add, as Aubrey and Reason have said for many years now, they won't buy many extra decades, right? 10 to 15 years, maybe a little more if you're really good about it. Advanced intervention should be able to do better. This is Foresight, and we believe in advanced technology, and I certainly think they should be able to do better, and that's obviously the goal. And that's why we're here. But in the meantime, we can't be fooled into inappropriate thinking and overgeneralizing conclusions from effect sizes of easy to beat controls and have unrealistic expectations. So let's talk about a little bit of that. So more of a good thing's not always better, right? Or better for everyone, right? Just because vitamins are good doesn't mean you should megadose. NAD plus precursors may have negative effects. COVID vaccines are wonderful, and some people need boosters, and that doesn't mean we should have boosters every 4 months. Most biological variables have U-shaped ranges, and the ideal thing is to quantify, where we are in the range, and that kind of seeing what's actually happening should be built into trials in good science. Hooking black boxes, right? Most trials are just, here's the body of the black box. Let's give it something and then see what happens with the functional readout at the end. And there's not enough seeing what's happening in the middle to make sure that the right things are happening that you thought were going to happen, and to understand whether the dose is right. So we need to query intermediate steps more. Human data is not always better. Certain companies and other people in the field like to poo-poo any animal data and say that, because it doesn't always translate, that human data is always the best. But the problem is human data is hard to get. It's much harder to look inside the black box of human, because of course we're not allowed to harm them.
Isn't that an argument like searching under the spotlight? Because it's character doesn't mean it's not.
No. So ask it in the Q&A and we'll talk about that more. So it's important to use human data, but it's also important to use model organisms and organoids and in vitro and basic theory and epidemiological data. A lot of those things can be combined together to get better stuff than just human data.
Right, we're at 2 minutes right now.
Great, I'm almost done. So RCTs don't trump all other types of data. They're slow, they're expensive. So what are the lessons? So last slides. So there's a bunch of lessons I'm going to try to synthesize from all this, right? If the control group, here's what, if you see a study and you read about it, somebody posted on Twitter, whatever, here are the questions to ask yourself. Is the control group right for the conclusions being claimed? Was the study population reasonable? Was it an unusually worse study population for some reason? Leon Peshkin likes to point out that some of the mouse studies, the controls live much worse, die much sooner than in other studies. What's the mechanism of action? Are the variables that are relevant tested to see, where the population was? And is the effect size finish that one? Is the effect size likely to vary across subjects? This is very important, right? If you've got unhealthy subjects and healthy subjects in your control, do they both get the same effect size? Right? Joe said he'd be happy to get that 10 years if it was a CR mimetic. But then the people who are thin aren't going to get their 10 years from retro. So Joe, give it to me too, please. So how do we design better science based on some of this? So, science is much more repeatable. We had a question earlier about repeatability. Science is much more repeatable if we've got smaller steps. So we get smaller steps if we query more of the independent variables in the sequence of a sort of a pathway or a causal sequence. So interventions that ideally have tests to see who needs them, and because it's not everybody all the time, and to ideally trials and studies should have longitudinal testing to see if the mechanism is working and to know how to adjust dose if it's not. Titrating dose. Most things should not be fixed dose. They should be how much does this person need, titrate the dose to make sure the physiological variables go into the right zones. All right, and that's it. Long-term progress in aging, just to bring it back to aging, monotherapy effect sizes that are within the 10 to 15 years achievable by lifestyle are less interesting in the long run. They might be interesting in the short term. They might really boost the field and get it on the map with a broader set of people. But in the long run, we want things that are better than what you can do with just lifestyle. And I think what the field needs for that is better ways of seeing inside and heuristics for what constitute the interventions that will be able to be combined better. In order to get to beyond the 10 to 15 years achievable by lifestyle. Which ones will combine the best? Well, that's a good question. Maybe the ones that address several aspects of the aging, and so that you can then combine them and actually get a benefit. All right, that's it.
Awesome. Well, open the floor for questions. Here we go.
I'm curious, this is a great set of recommendations for people who are actually going to go and read the studies, but in terms of the communication beyond the scientific community and the popularization of some of these ideas, any recommendations for how to generalize more accurately?
Yeah, I mean, this is a good question. So the question is, if you're going to go read the study, then that's great, but what about the broader public that's reading the mass media coverage of the science? And, that's actually where we get the biggest problem, is because the news media and the social media reposters will often lose some of these details, but oftentimes they do have the seeds of the details in them. Some of the popular press will describe the study, and sometimes you can't actually answer some of these questions that I suggest asking about the study. Some of these are in the news article sometimes, and I guess my heuristic rule of thumb is if these details aren't in the popular press coverage and you don't want to go at least read the abstract of the study, which is actually pretty easy to do for a lot of lay people. It's the details of the study that are hard. Then just don't trust it. Certainly don't go. One of the things that caused me to decide this is something to talk about is all the misinformation that we have seen during COVID. But it's not just about COVID. There's been misinformation about all kinds of longevity things too. It's amazing how many people are taking some of these longevity things who are in their young 30s, and they're only just taking it because they saw that this did something in mice, and they have made no attempt to decide whether their life is like the mice of the study that caused them to be inspired, right? So yeah, there's no substitute. You just don't trust to do anything if you're not going to read something that's going to give you some idea.
So I came in a couple of minutes late, so I might have missed it, but I'm curious, given all the time you spend reading all these studies, what have you personally decided to do?
I eat a whole food plant-based diet. I exercise both resistance and cardio multiple times per week. I try to sleep enough, and I don't drink alcohol or hardly at all, and don't use any recreational drugs. And I pay a lot of attention to when the other things are going to be ready to actually be likely to do more. So
That's pretty good for
I take supplements, right? I mean, I take a bunch of supplements that are important to make sure that you're not in the right in the wrong zone. Typical stuff, vitamin D, omega-3. I take a little bit of creatine because I'm vegan. I'm trying to lower homocysteine, et cetera, et cetera, et cetera. But nothing in the pharmaceutical category of metformin or rapamycin or anything like that.
Gotcha. And it's you feedback loop where you're like doing specific blood tests and adjusting, and if so,
Certainly the supplements, right? I test my omega-3 levels and my vitamin D levels and a whole bunch of other stuff. My homocysteine, there's a bunch of blood test vendors, direct to consumer, where you can order your own blood tests, and your doctors can recommend some too. And there's a whole bunch of good stuff, and people talk about this stuff on like the CR Society forums and other places.
sweet.
I was just curious if you've done any measurements, methylation or biomarkers before making any change. If you have one particular change that should you most increase in those results or any.
Like many people, I started doing the right things and doing the right tests kind of at the same time when like suddenly I was like, oh yeah, I should be a little healthier. So the only interesting data point I have anecdotally of my own personal stuff is that I changed a whole bunch of things at the same time and I stopped getting sick. And the things I changed were I started doing reasonably good levels of vitamin D, omega-3, cardio exercise, and I think maybe one other thing I can't remember right now.
A lot of what you said is resonating with me, especially in my company. We see a lot of people testing and actually taking a lot of medicine, so which is not always anything. But I wanted to hear your opinion about this new kind of cool term called citizen science. And what do you think about it, especially in terms of energy?
You mean in terms of like people doing experiments on themselves?
Yes.
Yeah. I mean, I think that it's very clear that there's going to be a lag. There's two aspects of people experimenting on themselves. One is that they're just trying to actually get healthier. And it's very clear that the therapies will come along and be available via certain channels. And there'll be a delay before they're fully approved and become standard of care of the classic medical establishment. And so if people want to do that in an educated way, I think they should be able to, because it's their body. The other aspect of it is the science part, like we said, is collecting that data. And people should self-experiment on themselves if they want to know what their body's reaction is and they're trying to tune their own health. But it's much, much better if we aggregate the data across everybody and other people can benefit. And that's a whole giant can of worms of how to best do that. And there's lots of people within the longevity and aging community who are dedicating their careers to that problem. And that's beyond the scope of what I'm qualified to talk about. Aaron mentioned that he borrowed this test for AGEs that people could do at lunchtime from OpenOhm. Kevin Parrott's one of the people who was very interested in that, but there's many, many others. But beyond the scope of my qualified to either right answer. So, yeah.
Yeah, I think one of the big issues, Karl, is coordinating clinical trials. I mean, when COVID showed us, we had, 80 trials on hydroxychloroquine, 30 on ivermectin, and none of them were powered enough to give you any results. And, that when you do a clinical trial, you have to really coordinate or get people involved on it. And then the other thing is, using real world evidence or comparing control groups against each other. You don't, when you do exercise, you can't have a placebo. you know, you have to compare, you know, but to get enough data to really make realistic comparisons.
COVID experiments are a good example. It's very disappointing, right? We know that rate of aging is affectable by a number of things, lifestyle, and a number of the things that help determine or predict whether somebody is biologically older or younger than their actual chronological age are very clear, are even part of standard medical records, right? BMI, a number of inflammatory markers, right? And yet we also know that age was the #1 risk factor for COVID, and yet almost none of the COVID clinical trials stratify their data by some other measure besides age that quantifies biological age, right? A lot of the, tests of vaccine effectiveness, treatment effectiveness, whether it's hydroxychloroquine or Paxlovid or whatever, would love to have seen that data stratified by some overall biological age estimate, but no. So that's tough.
Many of the things you find out very bad and are being a bigger problem behind that is that I think most of these things are an accident. Very few ended out there who are incentivized to put out the content. They have just put out like an image, companies. So how do you think about that? How do we solve that?
Right. So let's see if I can clarify the question. You can correct me. So part of the problem is that the people who run the studies and put out the data aren't incentivized to give the caveats, and they want to make the study and the thing look as good as possible. So and this is one of the reasons that the program lists my talk's title is what I've learned from tracking the longevity companies and also implicitly investing in them. And obviously startup companies and people with therapeutics want the worst possible control, because then the effect size looks the best, right? The best way to get a high fraction is to lower the denominator, not make the numerator higher. So how do we deal with that problem? Well, there's nothing wrong with that system. That system is good because we need the companies incentivized to do the best, and everyone should be competing to try to claim that their thing is good as long as they're not lying. But then you as the consumer and we as the scientists discussing it all, it's up to us to be applying the lessons and asking the right questions and figuring out who the controls are and reporting it in non-biased ways and considering whether to use it in ways. So it's not really I think
like a good rationale for having something like an FDA.
The FDA's job should be to make sure that the data is honest and and then we should have honest ways to pit different things against each other in reasonably clear, fair competitions.
But they don't want
all the other problems with the FDA are beyond the scope of this software.
And that's something that really needs to be done. I think people are going to realize that.
So
one more question.
FDA is a little beyond the scope here.
We're over here.
Okay.
So we have all these early adopters of promising graph that is so nice. They're just bridging the path between mice and human trials, right? So what's the pathway and how long is it going to take to test?
So how long does it take to go from mice to humans?
Yeah. And what's the path?
Well, this is a great question. And I mean, this is the part of the big question, right? So it's not easy to do some of these intermediate step observations in humans, where in some ways not even easy to do in mice in the earth, because we sacrifice a fraction of life every so often, for example. But not everything translates. So it's a big question. I mean, I think there's no one right answer, right? There's organoids that can be human, there's humanized tissue put into mice, there's different ways to modify mice to make them more human. Some of these fail spectacularly, and then there's other model organisms, and there's epidemiological study, like I said, in vitro study, and you just have to combine all these things. You just have to try to make progress. But I think part of it's going to be like we're going to see big improvements from new technology that's hard to predict, where we can do better non-invasive testing, things like that. But I don't think there's a magic story on how to get from mice to humans, and it's not clear how long it's going to take either. Until we get, for example, if we could do 30% life extension in mice now, who knows how long until we get.
I think it depends what it is, Carl. It's relatively safe. So,
Yeah, I couldn't
you
get
know,
questions.
you go, but if you're doing, genetic therapy.
Right, but we don't know if it'll actually translate well enough.
Yeah.
All right.
All right, sounds good. Thank you for talking. Okay,